In tutorial 3, I showed you how to design a microstrip patch antenna. The video was all about the geometrical construction of the antenna. In this video, I'm going to demonstrate how to simulate the antenna which I designed in the previous tutorial. You will not be able to simulate any system unless you complete a few mandatory steps. First of all, an input port must be defined. Roughly speaking, a port is a place where the power is propagated into the system from outside. In this case, the antenna is the system, and CST Microwave Studio supports two types of ports, waveguide port and discrete port. I'm going to use waveguide port with this antenna, and this kind of port simulates an infinitely long waveguide connected to the system. The size of a port is an important issue because large-sized ports will allow higher-order waveguide modes to propagate in the port. And the important thing to remember is that I have used a microstrip transmission line to feed the antenna. And whenever a microstrip line is used to feed the antenna, a basic rule regarding port size must be followed. Look at this figure to understand the concept. This is the substrate, the ground plane is at the bottom, and then the microstrip line is at the top. This is a side view of the antenna, and the intended port is marked by pink color. The rule of thumb is that the width of the port must be 6 times the width of the microstrip line WF, and the length must be 5 times the substrate thickness H plus the ground plane thickness MT. Now let's go to CST environment. This is the antenna, and we have to define a port in this area. Zoom this area in such a degree so that the thickness of the microstrip line becomes visible. Then go to Objects menu, select Peak, and then pick Face. Double click on this face, and then go to Solve menu and select waveguide port. Since this is the first port, so the name is 1. Now let's come back to that figure and notice the orientation of the axis. The y-axis is normal to the port. Therefore, the y-axis is already selected as a normal axis of the port. Again, I would want you to look at the figure. The width of the port is along x-axis and the length is along z-axis. Therefore, the half of width is along negative x-axis and the other half is along positive x-axis. Now let's find out the z coordinates. The 4h portion of the total length falls in positive z-axis, and the h plus empty portion falls in negative z-axis. Now come to the position field and define the corresponding coordinates as found from the figure, and make sure that the distance to the reference plane is 0 and the number of modes is 1. Press OK to finish the port settings. You can reduce the size by pressing the space bar from keyboard. Here is a port marked by red color. Now let's proceed to the remaining steps to start the simulation. Check the unit settings from Solve menu. Already they are defined. The next step is to define the range of frequency in which the antenna will be simulated. A large range of frequency would increase the simulation time, so define a reasonable range. In this case, we already know the antenna resonates at 1.8 GHz. Therefore, a reasonable frequency range can be 0 to 2 GHz. The next step is to set the field monitors. A successful simulation can provide a bunch of results. Definitely all results are not matters of interest. Therefore, it's up to the user, and he can pick some particular fields of interest which he wants to get from simulation. Right now I want to observe the surface current and far field radiation pattern at the resonant frequency. So select surface current and define the frequency 1.8 and press apply. Do the same for far field radiation pattern, and finally press OK. Every field monitor is set up. They will be listed in this folder, and you can delete from here or create new field monitor from this folder. Now we are ready to start the simulation. CST has 6 simulation solver tools, and they have different users depending on different factors. For antenna, we have to use transient solver. This is the solver settings window. For more accurate results, you can set the lower dB levels, but it will increase the simulation time. Minus 30 dB is fine. Leave these settings as they are and check this option. Give a value of 50 ohm. You can also check the adaptive mesh refinement to enhance the accuracy, but remember it will increase the simulation time. We are done with the settings, so press the start button to simulate the antenna. You will see live feedback of the simulation processes in the message window. You can also pause or abort the simulation from here, and it might take some time to complete the simulation depending upon the speed of your computer. That's all for today. I hope you have learned how to simulate the antenna, and thank you for watching this video.